Okay, looking at this next problem is looking for the density of a cubic shaped object measuring 12.4 centimeters on a side, and the mass has 98.40 grams. So we're going to use density is equal to mass divided by volume. And in order to get the volume, we need the volume of a cube. Now the volume of a cube is side cubed. Now the cube here is 12.4 centimeters on a side, so it's going to be 12, so the volume is going to be 12.4 centimeters times 12.4 centimeters times 12.4 centimeters. And that's going to come out in the calculator to be 1906.624 cubic centimeters. Now the thing is that since I'm dealing with division and multiplication here, I'm actually going to keep all of these significant figures until the very end. Then I'll go back to the problem and I'll figure out how many significant figures the answer should have. I'm not mixing operations here. I'm only dealing with multiplication and division all the way through. So that would be the way that I would end up getting my significant figures at the end. So then what I would do is I would say to myself, well, I've got 1906.624 cubic centimeters. That's going to be my volume. Density is equal to mass divided by volume. So the density is going to equal the mass, which is 98.40 grams, divided by the volume, which is 1906.624 cubic centimeters. Now the final answer here is only going to have 3 significant figures. That's because when I look at the problem I can see that this has 3 sig figs, this has 4 sig figs, so my answer can only come out to be 3 sig figs. So I'll go ahead and do that, and that's what I come out with is 0.0516 grams per mil. Alright, looking at the next one, we've got a rectangular block. We've got a mass here for the rectangular block, 640.00 grams, and we've got its dimensions here as well. Now in order to get the volume, we're going to do the same thing as we did up here. Now the volume is going to be length times width times height, and that's going to be 12.00 centimeters times 18.00 centimeters times 0.75 centimeters. And that's going to come out to be 162 cubic centimeters in my calculator. Now I know that the density is going to be given by the mass divided by the volume, and the mass here is going to be 640.00 grams over 162 cubic centimeters. And that's going to give a final answer there of 4.0 grams per cubic centimeter. Now looking at the number of significant figures, what I did was I just multiplied all this out and I was left with this one, which technically has 3 significant figures, but I carried that all the way through down here because right throughout the problem we're just dealing with multiplication and division. So that's what makes the most sense. Rather than rounding here for significant figures, what I'm going to do is I'm going to round down here for significant figures, and I'm going to come out with my final answer. That's what it's going to be, 4.0 grams per cubic centimeter. But looking at the number of significant figures we actually include, we've got 5 here, we've got 4 here, we've got 4 here, and we've only got 2 here. Remember, the 0 is not significant because it's a leading 0. So our final answer can only come out with 2 significant figures as well. Alright, looking at the next one. We've got a researcher adds water to a graduated cylinder to the 30.0 mil mark after measuring a mass of the object to be 48.40 grams. The object is immersed and the new water level becomes 38.5 mils, and we need to find the density and specific gravity. Alright, so looking at the density, we know that density is going to be mass divided by volume. We actually already have the mass, it's 48.40 grams. What we need is the volume of the object. Now if we know that the graduated cylinder was 30.0 milliliters originally, then it went up to 38.5 mils when we added the object. We could find the volume of the object is going to be 38.5 milliliters minus 30.0 milliliters. So when we do that, we're going to come out with 8.5 milliliters. Now looking at the number of significant figures here, we're going to deal with a number of decimal places because this is addition and subtraction. This has one decimal place, this has one decimal place, so the answer actually has one decimal place as well. So that's correct as far as significant figures go. Now I want you to remember here we are mixing operations, that is, we're doing a subtraction and division first, and then we're going to do a multiplication and division. That's why it's necessary for us to actually get the correct number of significant figures here once we're done with the addition and subtraction, and then we can use that figure in the division multiplication part of the problem. So we know that density is mass divided by volume, and that mass is equal to 48.40 grams. And the volume here is 8.5 milliliters. So that's how we end up with 5.7 grams per mil as our answer, which only has two significant figures. The specific gravity, what we do is we take the density and divide it by the density of water, which is 1 grams per mil. So that's how we end up getting 5.7 grams per mil divided by 1 gram per mil. So those will cancel, and we're just left with 5.7 for our specific gravity.